Hello and welcome back to this mini-series about Java Reflection API, where we try to rebuild and recreate common libraries that are reflection-based. So today is the day where we finally start with the dependency injection framework. But if you're new to Java Reflection concepts, you can watch the previous videos where we built a JSON mapper and annotation-based validation engine. So what is a dependency injection? I guess let's go back and understand what problem does this pattern solve. We have here an out service that has two functionalities: registering a user, providing username and password, and trying to log in with the given credentials. So it returns true or false if the credentials match or not. Out service itself consists of MySQL connection. When we're registering, we're taking username and password. We are hashing the password so we don't store any plain text using the bcrypt module, create user details, and save them into the database. So for the login, we take the username and password. We try to find this user if it exists in our database, and hash the provided password. If it matches, it means the user has provided the same password. For MySQL connection, it's just a mock connection. So we have some mock connection string, we have some map that is storing key value pairs, where key is a username and the user details, and we just ask this map to get the user details by username and put them by username. And we have this mock in place, so we don't have to run real connection to MySQL database. Now that we have seen this example code, let's understand where is the problem and where we can apply the dependency injection. So let's look at this example. We have an out service that is consisting of two dependencies. One is MySQL connection, another one is bcrypt hashing module. These two dependencies are being hard-coded inside that out service. So anyone who will use it needs to have a MySQL database connection. But what if MySQL is being deprecated and we need to move to any other database? Or there was a found vulnerability inside the hashing function, making all the hashes we store insecure. Or another scenario, we would like to unit test our out service, but it is making a live connection to database. No unit test should make that. So instead of that, we would like to provide a mock implementation of our database and just verify that the correct data is being provided to it. And here where dependency injection pattern comes into the play. So instead of hard-coding out the dependencies and creating instances inside the class, we want to have them being provided from outside, being injected inside the class. And usually this is done by a constructor. So we list all the dependencies that are required and ask outside to provide it for us, meaning that someone else is responsible for creating a database connection. So right now we are hard-coded to a local host, but maybe we want to connect to some managed solution. And that's why we predefine the connection outside and pass to out service what it should use. And now you probably start asking yourself, is all this fuzz just because of a constructor? Usually it is handled by some framework, which create instances, components, and inject them inside our classes automatically without us doing any manual work. Dependency injection is very powerful when it's used together with dependency inversion principle. Dependency inversion principle states that higher level modules should not depend on low level modules. So you can imagine that most of the software is using other components. So one component could depend on two more, which could depend on three more, and etc. And there is a quite large tree of dependencies being built, and if any of them has an issue or a change, it means that every class in the chain needs to handle it. That should not be the case. We should not be affected by this little change in this lower level module. So how we can solve this problem? By introducing an interface in between our components. So each time there are integration between two components, ideally there should be an interface between them. Our higher level module depends on the interface. So meaning that as long as the interface is not being changed, we can safely use it. So let's now apply this principle and pattern and see it in action. Instead of hard-coding MySQL, we want to extract it as a separate component. Then we want to define an interface that will list all of the functionalities that we need for our service. So MySQL is quite large class. It can hold many things. It can create views, it can create databases, much more, but we are interested only in storing and retrieving a user. So an interface with these two functionalities makes much sense than receiving all of the MySQL functionality. So now instead of hard-coding a MySQL inside our class, we can create a variable, type user repository, find it in our constructor as a dependency. So when someone creates an out service, it needs to provide a user repository. So now we are not depending on any concrete implementation and we are free to use any. It can be MySQL, it can be a Postgres, it can be anything else as long as it is implementing this our user repository interface. And now it's just like a plug and play. We can inject our MySQL connection back. Now we want to do the same thing for our bcrypt module. Instead of relying directly on it, we would like to define an interface called hash function. But sadly, we cannot do this because bcrypt is not part of our source code. So basically our interfaces are not compatible. If only there was a design pattern that addresses this issue. Right, there is. Adapter pattern. Adapter pattern will wrap the bcrypt module directly inside and implement our hash function interface, making all the necessary changes to make our interfaces compatible. And here comes the beauty of our dependency injection. You can imagine we want to switch database or mock the implementation during test, and as long as all the components depend and implement the same user repository interface, it removes any friction of us switching the implementation. And testing becomes really simple because we can always provide a mock and just verify that correct data is being provided. And just like that, we have created a modular system where we can just provide an implementation as a plug and play, as a puzzle pieces, connect them together. And as for today, to make things simple, let's refactor the code to use the dependency injection via constructor and dependency inversion. Okay, let's start. So first component, our higher level module is out service. It is dependent on two things, MySQL connection and this bcrypt hashing module. Let's start simple by creating a constructor that will accept a MySQL connection. And instead of creating instance here directly hard coding, we will provide it from outside. And we would like to do the same thing with the bcrypt, but the bcrypt is a static function, and you know static functions create a tight coupling, and we cannot just extract that simple. We could use functional interfaces, but let's keep things simple because anyway we will need to provide an interface later on. Let's just focus on MySQL right now. So now that we have extracted it here, it means that we are no longer hard-coded to one connection that has been created inside. Now we need to here create a MySQL instance. And we can provide it inside here. So now, from outside, we could have one single database connection that can be passed and injected in all the modules that we would need via constructor. Or, for example, if we create another connection to, for example, want to have to another database, we now could replace the implementation and provide the connection to other. Except currently, if you open MySQL connection, we are saying that it's connecting to same database. So basically, we are mocking the idea. Of course, you should never hard-code your connection string or any connection parameters. This class should be generic enough. And this class also can benefit from dependency injection, because what this class depends on connection string. So you should always provide this from outside. So let's provide a connection, and with the same dependency injection pattern, it could be read from properties files and injected inside. And we could get rid of this hard-coded connection string and use this specific one, making this class more generic. So if I return back, now I need to provide it here, inject which connection. So for example, this could be a local connection, and other one could be some sort of external host database. So now we have implemented the most basic dependency injection without inversion of dependencies. So you could imagine the MySQL connection actually could have more functions. It could have a function that can create table, which is really not relevant for our use case. And by providing this large dependency, we provide everything, even those things that we don't need. What out service really does rely on is the option to get the user details and the option to save user details. And to make this dependency inversion work, we need to create an interface that will hold only these two items. So let's implement a user repository interface. These are the only two operations we need from user repository. We don't care what it is a database or in-memory store, as long as it can provide this functionality. Now going back to the out service, you can see now that it depends on MySQL connection. There is no other way how we can provide a Postgre database or mock database. But now, thanks to this inversion principle, we can provide here an interface. So instead of MySQL connection, I can provide a user repository and rename this variable into user repository. I'm not depending on MySQL connection. I want just to use any user repository as long as it fulfills its job. And you can see nothing changed in our code because we depend only on this user interface. So if anyone is interested to use our authentication service, it must follow the user repository. If not, we are not accepting this dependency. So now for the bcrypt part. We would like to also have some sort of interface here, for example, hash function. And we would like to also inject it inside. So let's create this interface. And it should just do two things. One should be the hashing, Another one would be the matching function that will compare the hashed against the plain and see if they match. So now here, instead of hardcoding the bcrypt, we can leverage our hash function and ask to hash the password. And in the login part, when we check the password, we also want to leverage our hash function and match it between stored password and user provided password. So now last thing, to remove any information about the bcrypt hashing function, the import from Spring Security. Cool, now we need to inject it from the outside. So here we would like to define our bcrypt hashing function, but we know that the bcrypt is external code base. We cannot just add here implements because nothing will be added. And as we just discussed, we need to implement adapter to match the incompatible interfaces. So then let's create a bcrypt hashing function and let's create our bcrypt adapter. So bcrypt adapter itself will implement our hash function. And now we can leverage the bcrypt and hash the password using some sort of salt. And for matches, we can again leverage the bcrypt's check password function that will take password that is being provided in plain text and the one that is being stored in DB. So now we have aligned the bcrypt interface into our adapter, and we can successfully now inject it inside our class. And just like that, we have implemented our dependency injection through constructor using inversion principle. So now for the good part. So here in the test, we actually could use something different implemented for the user repository, so we do not need to create a real database connection. We, for example, could define our own mock user repository that will just implement the user repository that we have and provide some implementation for it and just here use it, new mock user repository. Or we can leverage any mocking library, for example, like Mockito. So instead of creating my own implementation, I can just provide a mock of my user repository class. So now I have injected a mock inside our class. Let's follow the given then section. Now I would like to save and register a user. So John and password would be QWERTY. Now I need to verify that actually my database got invoked. So for example, again using Mockito, I can ask if this user repository, there was an invocation of save user details, for example, with any input. So indeed we can see that there was one invocation of save user details with some sort of record. But we would like to actually verify that the saved information is not plain text. One way would be with the argument capture. We could capture what has been provided inside this function and verify that the plain text is not being matched. But really, this is out of scope of this class responsibility. This class only needs to call the hashing and store what hash returns. Instead of bcrypt adapter, I could also mock it using our Mockito framework. And now I could set up a mock action. So when someone on hash function calls hash with property QWERTY, it should then return a hashed password. So now, instead of me capturing the input, I can just here verify that the save user details got called with the following object with the username John and password hashed. So by this I can unit test my authentication service without invoking any real implementation that could be provided here, as long as I have proper mocks set up. So let's run to confirm that everything works. And indeed we can see that user has been registered with John and hashed password. And just like that, no actual implementation of user repository or hash function was involved in the testing. And thanks to the dependency injection and inversion, we can just simply plug and play the implementations. So in this little video, we quickly covered what is dependency injection and how it works, for what purposes we use it. And we implemented the most simple case of dependency injection via constructor, where we can just provide dependencies inside it. We covered the importance of inversion of control, that our higher module should not depend on low-level code. Instead, they both should implement and depend on the interface. So when one module wants to use a one dependency, they both agree what are the implementations required. If you're using third-party code or interfaces are not matching, you can always use a dotted pattern to enforce it. And by this, we made a modular plug-and-play system like a puzzle. You can just connect pieces together. So now that we have finished with the basic part, next time we will start with the framework, and we will make these things auto-injected in our code. So we could only list what dependencies we need, and they would be auto-injected to us. If you like what you see, please leave a comment. I still have not received any comment.
You can be the first one.
Subscribe to not miss next part. But until then, keep coding and see you next time.